recording. All right, so let's continue. Okay, so work, energy, and power. That is a chapter we are doing today. So, what are the things we need to know about work, energy, power? Okay, chapter 4. Okay, the most important thing that you have to remember is what is the definition of work done? Okay, work done, so we can use two methods. Either you give it in Newton meters, Newton meters accepted, or you can just give joules. Both accepted. Okay, right. So what is work done? Okay, work done. Okay, according to the definition, is okay, work done by a force. It has to be a constant force. Okay, the force cannot change. Okay, so the force it has to be constant. Okay, constant force. So that wait, really, you know what? Maybe I'll fix it. Yeah, this is better. Yeah, this is better. What is going on?
Which
Okay.
is the constant?
Yeah, I'm gonna write that down now. Okay. So work done. Okay. We can use W. We usually denote work done with W. Okay. By a constant. And use F. We leave F in, so that the point. Oh, this point is up. Erase this first. Maybe a little bit. Do that here. Extend. The point of application of force is displaced by displacement of displacement S. So we use S for displacement. Okay. Uh, let's see. Okay. Work done by a constant force F so that the point of application of force is displaced by displacement. It, it looks a bit scary. It looks a lot like a lot of things you remember, but not really. Okay, all you have to remember is that W equals to a vector value of one, okay, and dot product S. Okay, both are vector values. That's all you need to do. Okay, that's in this entire chapter, we just only play around with this theory. Okay, everything else is always derived from this. So where can we start? Okay, let's start with the question one. Okay, let's see how to apply this thing. Okay, let's go with question one. Okay, the variation of force, the x and object and the direction of x. If the displacement x is shown below, calculate the work done by the force. Move the object for a displacement of 8 meters. That is 8 meters. So sorry for the scan. I'm not sure why that's happening. But let's try to solve this one. Yeah, I'll try to work this one. Okay. So like now, just now I mentioned, okay, the tool was given just now. Work is just a vector product of force and also the displacement. Okay. So this is the force and this is the displacement. Okay. So all you have to do is just find the area under this graph. Okay, so this is a trapezoid. So how would you find the area under this graph? Okay, but that's very simple. It's just 1 over 2, take 2 of the height, so that's 4 plus 8. Okay, and then you times with the here. Okay,
4.
what's your answer? You should get
24
24 joules. Okay, that's all.
Newton meter.
Yeah, you can give joules or Newton meter. Both are exchangeable. Both are exchangeable. Okay, the question, okay, sometimes it will be a bit complex. Maybe the energy has to change, or you have to input the energy somewhere else or whatnot. For those parts, yeah, keep it in Newton meters because they might only want you to find divide back. Maybe they give you the energy, they give you the work done, and then they tell you, okay, find the displacement. You can go backward also. It doesn't always have to give you this and this to find your work. It can sometimes give you the work and then ask you for the displacement or ask you for the force. For those, yeah, maybe you can give it in Newton meters first. But if generally they ask for work done, just give it in joules. Let's try question 2. When these are all short questions, so I'll just go along with you guys. When a gas expands, the piston is moved to a distance x as shown in breakdown. Yeah, it's moving. Okay. But first, yeah, this is the gas here, so it's moving and the piston is going up. Okay, and this is the final position of the piston. If the pressure of the gas is P and the cross sectional of the area of the piston is A, find the work done by the expansion. Okay. For this one, you do not need to do it. It's all in the terms given. How do you find the terms given? Okay. Initial volume. Okay. What is the volume of any cylinder? You can also say it's a base times height. So you just say distance. You don't have to go into pi r square because they already gave you cross sectional area is A. So it is A already given. And that's given N, X, L, P, K, all that. Okay, they already give you all the things that you need to use. Okay. So the initial volume, okay, VI equals to what? AL. Okay. The cross section area is always the same, so A equals. Okay, then your final volume would be, sorry, final volume would be A. So A, then you have to add both of these. Okay, L plus, okay. So the increased volume, or you can say the delta in volume is equals to delta V R, delta V equals to A L plus X minus A L. So we just give you with A. Okay. So what do you do with this? Okay. You have to also remember work, you can also do it as P D V. Okay. PdV. Displacement, volume, pressure. Okay. So you can also write P A. Oh, sorry. Capital A, right? Capital A was used for the displacement. Keep it as then X. So W can also be Px. Okay, let me just write this down. Pressure.
Can I do like this? P equals to F over A.
E equals to
And I
F.
just
Okay.
F equals to PA. And then just times L plus X.
L plus X. Okay.
Is it correct?
At the end of the day, if you get this thing, PAX, then you're good. That's
So
all.
how to know whether to plus the L or not?
Okay. You have to see what they ask is find the work done. Find the work done
Mm.
by the gas. Okay. So when they say work done by the gas, since they say the gas is expanding. So at this point, let's say at N, so they say N is the initial point. Yeah, N is the initial point. So they only want you to find from N to this point here to here. Okay. You can straightforward also say you don't have to do all of these VI and VF. You can just straightforward say work done. Okay, the delta V. Okay, delta V is just AX. Okay, because you know from here to here is already X. Okay, and you know also that F equals to pressure times by cross-sectional area PA. And the displacement is X. Okay, also I simulated X here now. Okay, so you can just do the same thing. Okay, what is W? Okay, work done. First F S. And F is a P. And then the displacement S is X. So end of the day, you still get the same thing. Why if you're asking whether we should know if it's L plus X or not, okay, I remember what is the initial conditions. What is the work done? Okay. If you ask for work done, it's always a delta. Okay, it's always going to be a change. So when I keep where is it changing from? So you can see here they give you the lines here. Okay, it's changing from this position to here. Okay. So that's how much work is being done on it. So maybe before that, work was put into, okay, on. So work was on the gas. Okay. Example, maybe they squeezed it first, and then the energy was stored, and then the work was done by the gas. Okay. So we don't know those conditions yet. All we know is it expand and move the distance of x. That is all the questions give us. Okay. So that's why yes.
AX is the F or S?
Ax is, remember what we just oh, you're asking what it is. Oh, okay. Ax is the delta of the V. So you can also use V here to find work also. Like example, this pressure, displacement, or whatever. It all comes back to your form 5 punya apa? Let me scroll again. Okay. Okay. Work done. Okay. Work done. Another way you can also write is actually pressure times by the change in volume. I think you remember in your chemistry, PV equals to nRT. Either
Yeah.
T changes or V changes. What is the SI unit of PV? You know, the SI unit of PV is actually joules.
Oh.
Yeah. So when I mentioned just now, this change, okay, PdV, okay. So AX is the change in volume and P is pressure. So volume is what is changing here, and pressure is constant. Okay? So you can also write it like that. Okay, so another formula, maybe you go to chapter 9 and 10, you will see the kinetic theory of gases. You'll see this amount. W equals to P dV. Or you might also see W equals to B dV. dP, sorry, dP. Okay. Either the volume is constant or the pressure changes, or pressure is constant and the volume changes. So for in this sense, the volume is changing. The volume changing AX, AX. But the pressure, we don't know. Pressure is constant. Okay, we don't know what's going on there also. Yeah, but you can do this one also, like you mentioned, your F equals to PA, and then you know it's F equals to PA, then you just multiply by X, that's the displacement. Both also can. In this chapter, everything is quite switchable. You can approach it from multiple sides. You can do it like this, like what I just mentioned, W equals to PdV, or you can also do it in the way that you also tried just now. It is using the form 5 method. Okay, using those TVs again. Okay, same thing. Okay, end of the day, you still get PAX. Okay, and as long as you get PAX, okay, let's go to the next question. A spring fractures 10 cm when it is suspended by a mass of 0.2 kilograms. A block which is attached to a sling spring is compressed to a distance X as shown in the diagram. Okay. Calculate the work done work done by the force is X is 50. Yeah. Maybe I can start off with that. You listen to. Okay, so the heat here still comes back to your home five physics. F equals to K. Okay, the constant, okay, the force constant, and also the distance. F equals to Kx. Okay, then this will become mg. Okay, mg also K. Y mg block. Okay, block as a force, as a weight. Okay, you have to remember that because they give you a mass here. Whenever there's mass, there's a weight. You always remember whenever there's mass, there's a weight. Okay. Would you like to try this? Okay, maybe you can take around 2 minutes to try this. Okay? We'll come back after maybe you try this too. Okay, let's try the question now. Okay. Okay. So okay, we continue back from here. Oh, please, okay. Let's continue back from here. Okay. So MGKXK. Oh, this is geometry one. Okay. So we know that M is 0.2, G is always constant 9.1, equals to K and X. Okay. So what is this X? Okay, this X is how this as the spring structure stands here. Okay, the structure stands here when it's suspended by a mass. Okay, maybe looking at it like this, you might not notice, but when you say it's suspended by a mass of 0.2, what it means is actually it's here. This point. Okay, this drawing is actually a bit get herring, okay? But it's actually suspended. Okay? That's why I also give you the clue that mg, and there's a mass that is bound to be weight. Okay, so this is what you need to. A spring stretches stands here. Okay, so this is where you take the tension value from. Okay, so when this is stands here, okay, right? You input here 0.1. Okay, 0.2, 9.81. You get k equals to 19. Oh, sorry, 19.2
6.
liter, -1. Okay. Okay. So what do you do with this k? Okay, this is where you do your find your work. Okay, come back to your form 5 again. Work in a spring is 1 over 2 k x square. This is based on Hooke's law. I think you should remember Hooke's law. Okay, this formula. Okay, W equals to 1 over 2 kx square. Okay. So here is where you do the here 19.62, and then they calculate the work done at the force is x is 15. Okay? It's 15. So here you put 1.5. In the end, I think you should get around 0.223 joules. Is it? Which is
Why, why did we use 0.1?
why do we use
Not
0.1?
0.15.
Okay, you have to see. Okay, so there's two things that here. You have to find two things that work here. One is the force. You want to find the force. Using the force, you want to find the uh, spring constant. Okay, you want to find the spring constant. Okay, so the force here, because it's suspended, a spring stretches 10 cm when it's suspended by a mass of 0.2. So that is your K. You want to find your K. Remember Hooke's law? The graph is a straight line. Yeah. So f and x is your k now. Okay, this will be your k. So you want how much it extends and how much of the force. Okay, we are assuming it's elastic. We are assuming it's elastic. Okay, deformation. Assuming it's elastic, it comes back. So it's a straight line. So we want to find the k here first. Okay, how we want to find the k here? We find it by how much it extends when you put a force on it. So in this case, the force on it will be the mass of the block. Okay, so using that, we find the k, and k is 19.62. Okay, so what do we do with the k? Then with the k, we find out, okay, a block is which is attached to the same string is compressed to a distance of x. When you're compressing it, as you did back to question, you're compressing it again. You're doing work. Okay? You're doing work on. Okay, they're saying the work done by the force. But what does this mean? This means you're doing work on the spring. You're doing work on the spring. So when you're doing work on the spring, okay, then you refer back to Hooke's law also. Okay? You do W equals 1 over 2 kx squared. Okay, here this how much is moving here? Only 15 cm. Okay, just now we use the tensor to find the k.
The
We're
F,
using
the F we can change to W.
F, you want to change the W, that's a lot of, because they only ask for work done. Because work done, you only need two things, what? The spring constant and the displacement. Okay. If you want to expand this again and say upper F x equals to 1 over 2 kx squared, then will be F. Then you don't know how much is this F. You don't know how much this F is. They only said of work done by the force. You don't know what is the force. You only know how much it displaces. If you want to find the force, can you find this? You find this, then you can say F equals to 1 over 2 kx. Okay, then you can find the force. But then you want to find the force, what's the point? You still have to find the, the that's what the question is. So we can just straightforward just use k and just use x. Okay. You can if the question, let's say the question is a part by part question, you ask like A and B, then C they ask like question A they ask for the spring constant, they ask for spring constant. The question B they ask for how do we know the F can change to W? How do we know the F can change to W? Yes, W equals to F, right? But here you okay, let's read the question properly. Okay. I'll skip the
If I use
okay, so what does the next question say? Okay, a pistol of mass 120 grams fires a bullet of 3 grams. Okay, pistol mass. The pistol recoils with a velocity of 10. Okay, so this is a momentum question. So you have to remember when there's question like this, principle of conservation of momentum. Okay, just write an acronym, principle conservation of momentum, PCM. I just usually write PCM. I write sometimes PCE. PCE is a principle conservation of energy. Okay, so these two lah. Either it's PCM or PCE. All this should be fine. All right, I have a try at the question.
PCM,
I know you cannot write this in the exam as PCM. Please don't write the exam in PCM. This is what I scribble in my paper lah. Hey, when they
okay.
ask for when they see a pistol, I remember PCM. Okay. What is conserved momentum? Momentum is conserved. It must be one of the three formulas. Okay. So this one I consider this one is It says recoil. Okay, recoil means always MB to MB. But this explosion, right? So explosive type is the sum should always equal to zero. So it'll be like MB minus MB equals to zero. So we say MB
Can you
equals to
repeat?
MB. Okay, yeah, I repeat. Okay, there's three types of momentum influence. I think elastic,
Hmm?
non-elastic, and explosive. So I think this one brings back your comfort memories. Elastic,
Mm-mm.
non-elastic, explosive. Okay. So for elastic, what does that mean? Okay, then you say okay, number one, MU plus MU. Okay, I will say two bodies. Okay, this is body one, this is body two. Okay, this is the momentum of body one, this is the body momentum two equals to MV plus MV. Okay, this is example would be okay, one thing here. Let's say it's a ball hitting another ball. Okay, hitting another ball, and then both of them move in two different directions. Okay, two different directions maybe after the collision. This is elastic. Non-elastic. Okay, non-elastic Mu plus Mu equals to Vm plus M. Okay, why Vm plus M? Okay, non-elastic means okay, both are
Move
sticking
together.
together. They stick together. That means they have the same velocity.
Mm.
And then T, explosive. Explosive means example would be there's an energy that is being given in one direction. There's an equal amount of energy given in the other direction. Comes back to Newton or solar. This goes back to Newton. For uh, for every reaction, there's an opposite reaction. Action, there's an opposite reaction at the same magnitude. So at the same momentum. Okay, some of momentum is the same, but the value might be different. So why? I mean, the velocity will be different. So why we say velocity? Okay, it's very simple. I can give you is a gun. No? Okay, in a gun, okay, uh, it shoots a bullet. The bullet is actually very tiny. It's very small, it's minute. Okay, like 3 grams or 1 gram. It's a very small value. So, okay. So come to the gun will be okay. They say 120 now, but actually in reality, the pistols are quite heavy, quite heavy, and the velocity is also quite big. Okay, the velocities will be quite big. Okay, so guns are the reason why guns are heavy. Actually, the gun is heavy because they want to reduce the recoil. Okay, remember it is a product of the mass and velocity. If the mass is very big, if the mass is very big, okay, so the recoil momentum will be very small because you have to give the same amount of momentum to move the say a bigger object. Like for the example I give you, a big ball and a small ball. Okay, so okay, if you pick a bigger ball and let's say you pick the same energy, pick both things, okay, the same energy, the smaller ball will travel further, right? The bigger ball will take only travel shorter distance. Same logic here. The reason why guns are not made so light is to prevent recoil and breaking arm. Actually, you can break the arm very easily just by recoil alone if you don't know how to operate a firearm. Okay, that's why most guns are actually uh, quite heavy. Okay, it's like at least 3, 4 kilos. You see PUBG, right? I'm just giving an example here. You know, see all the shooting games. Guy carries like a small guy, okay, no muscle also. Carries two AK-47, one in this one in this hand. Okay, and then got I don't know, like a knife on his hand, and then all the bullets, 300 plus bullets. So, and not a normal person will die. It's very heavy actually. Okay? I'm just going a bit out of
What
topic,
is
but just what is this? This is a question. I think you know like shooting games like PUBG. Have you heard before? So games like this where there's a very small person, no muscle also, but carry like two big guns. Okay? It's actually almost impossible. It's actually almost impossible. Okay? This is irrelevant to our class right now, but I just want to give you an example. Just do that. Okay, back. Okay. The last one will be uh,
Recoil means elastic.
no, explosive. Last one. Okay. mu plus mu equals to 0. It means that the momentum in one side is equal to the momentum on the other side. Okay, like a rocket going up. Okay,
Mm,
like a rocket
okay.
going up. Uh, so the propulsion is hitting one way, like the propulsion is going one way, and the rocket is moving up. Okay, so it's equal in moment. Okay, so this one usually we just say mu equals mu lah, close to 0. Okay, so for this one, recoil, if it says recoil or rocket or anything that's explosive, just remember mu plus mu equals 0. Okay, I hope this jogs back to your form 5 memories. I think I just solved it for you. I think it took a bit more time. It's gonna take M1 V1 equals to M2 V2. I said 0 just now. Okay, so
You are
that's
talking very
3
fast.
V1 equals to 120
No,
uh, yeah, and 10. So I just leave it as grams because the mass unit will cancel out. Yeah, I mean the mass unit will cancel out, and we only are interested in the velocity difference, the kinetic energy. Okay, so for now you can just leave it as grams. Okay? So you get V1 equals to 400 meter per second. Okay? Quite fast, huh? It's faster than the speed of sound. Speed of sound is around. And oh, I'm talking very fast, is it? Oh, okay. Okay, so where do you want me to come back again? Again? Okay. So we get V1 equals to 400 ms negative 1. Alright. So what we do with this, you use the formula KE. I don't know why they use KE, but the KE lah. KE equals to 1 over 2 and D. Right. Okay. They ask the energy of the bullet, so we just give energy of the bullet to 1 over 2. And now you have to do SI unit. Just now we didn't do SI unit because the mass units cancel out, but here mass units are cancelled. So I'll go for 3 times matter between 3. Velocity is 200. Okay. Then you'll get something along the lines of 240 joules. Okay, that will be your final answer. Okay, okay, let's go to the next question. Okay. Okay, same again, bullet. A bullet of mass. Okay, I just go with look through a question, scan for the keyword. Bullet, mass 1.5, fired, speed 1.24.
124.
Ah, okay. Concrete thickness. Okay, concrete thickness. Okay, why did they mention this? Okay, Pandey, right? Okay, let's keep that here first. Its speed is 92 after passing through the concrete. Okay, so this is one of those questions where you have to remember what is impulse. Okay, uh, okay, impulse. Huh? So it's got maybe I
Impulse.
can draw. Yeah, yes, impulse. Okay.
Okay,
I
okay.
think you remember impulse from impulsive force. When something is going down in a short period and then it stops very suddenly. It has a very high impulsive force. Okay? Maybe even though there's constant force, okay, maybe the force is constant, acceleration and everything constant. Okay. So even though that is constant, when it hits and lands, the change in velocity, okay? So the change in velocity, okay, F equals to uh, okay, delta what? And D over T, yeah, remember that. So this T, okay, maybe the mass is still the same, okay, mass is the same. So M dV with T, okay. In a very short period of time, this velocity is going from could be anywhere from 1 to 0 in a very short period. So the impulsive force is very high. Okay. Okay. So okay, for this question, I'll just maybe give you a diagram. Just take this out. You take that also. Start back the diagram. Okay, maybe I can give you a clearer picture of what's going on. Then you can imagine. Okay. So this is the bullet. Okay, the bullet is here. This is the point. It's going fast. What was the value given is now 1, 2, 4. Okay, this is the thickness. Okay, concrete. Okay, this is 60 meters, 60 centimeters. That's quite thick actually. 6, 0.3, 0.6. And then it shoots. Okay, it still comes out. Okay, it didn't stop it. Okay, that means it the retarding force. Okay, there's a retarding force. It comes out at 92 km/h. Okay, so how do you find this out? Okay, how you find this out? Okay, work is also the change in energy. Work is energy, right? So the change in energy is also work. Okay. So how, in this part, okay, since they didn't say the mass changes, if mass change or mass is constant. Okay. So when mass is constant, then I can say there is a change in velocity, right? There is a change in. So what is energy formula? Energy formula is 1 over 2 mk. Since there's a change in velocity, okay, I can see delta 1 over 2 m b squared. And in this particular situation, mass is still, okay, the mass is still constant, but velocity changes. So 1 over 2 m delta b squared. So it will be b1, b, okay, let's just use b minus u squared. Okay, so this is w. Okay. So how do you find the force? How do you find the retarding force? Okay, remember W is still, in this case, W is still Fx. Okay. And we know how much is a Fx. Okay. Since they only say retarding force, that means it's already negative. We do not need to mention negative. We do not mention negative. You can just say Fx. Retarding force already means it's negative force. So it's like slowing something. Okay. So you can just use Fx. Okay. Use capital Fx predominant. So in this situation, how much is it is being displaced by 0.6. 0.6. So all of the questions we automatically neglect resistance and all of the friction due to the error. Okay, all of that we neglect because they didn't mention and it's not really in your syllabus. Unless stated otherwise, I don't need to care about that. So let's just say it's a constant 124 before and constant 92 after. Okay, so F 0.6 equals to 1 over 2. What is the mass of the bullet? The mass of the bullet is 1.5 10 to the power of -3. Okay, then you minus the velocities. Okay, 92 squared minus 124 squared. Okay, you can put all of this in your calculator, you will get 8.64 newtons. So that is the retarding force. Adding. Retarding. That's the retarding. Okay, so you just mention this also retarding. It's your good. Okay, this one is a bit more straightforward now, okay? But maybe sometimes you have a problem where they say, how do you connect force and
If I write negative, if I write negative 8.64, will I get wrong?
no, you can still write negative also. But usually because, but if you want to write negative, the problem is right, because here they already mentioned retarding force. Retarding force is already a negative force. So if you write negative again, it becomes positive.
If the retarding force is impulse, then it's J equals to Ft mv minus mv. That one, right?
J equals to mv minus mu over T.
Mm, oh, retarding force means impulsive force.
Oh, okay, okay. The impulsive force I mentioned just now is just to give you back some memories now, okay? When something is slowing down. You do not need to use that here. Okay. I just mentioned the impulsive force here because it's something that is slowing down. But here it is not completely slowing down. You can also use that. You can also use that, but since they don't give you a time, okay, you can use impulse. Okay. I would say use impulse when there is a time. Okay. I just mentioned that because it's a similar situation. Like example, something is falling down, and there's a cushion, and the cushion is like slowing the object down. So there will be impulse. So the impulsive force on the cushion. Okay. And then usually they mention a time. They usually give you when they say impulse, usually give you a time. When it's a retarding force, usually they will just straightforward. Oh, I'm so sorry about that. They just straightforward go to uh, this energy. Okay. Driving force usually is a change in energy. Impulse, impulsive force, always time. Impulse, okay, even the word also, the word impulse sounds like that, something related to time. Okay? Something that happens instantaneously. Okay, that's instantaneous change. Okay? Yeah. So I just wanted to show you the similarity here. Not that we lose that formula. Yeah, my apologies
Okay.
that confused you. Okay, I don't use negative. Don't try to use negative if they already tell you it's negative here. If they just say calculate the force, then say maybe you can say negative 8.64. But that also is still depends on the question, okay? Depends on the question. If something is example, remember when we speak about projectile motion, then you can use
Mhm.
positive negative because that's where they really care about something is going up or down. Okay? Here they
Mm.
already know if it's going up or down. They already know it's slowing down and going up or down. Okay? So you can just leave answers because it will be fine.
For projectile motion, I must
Yes.
use the vertical component for everything except for the horizontal distance and time.
It's a vertical component for everything. It is not always the case, but yes. In the question, I think the question I tried to ask is, should I use the question to like v square equals to the square plus the two as
Mm.
somewhat all of that? Should I use u square and v square? Should I only use vertical component? Uh, okay, since this is only this is changing when it's a. Yes. Whenever you see acceleration, yes, use a vertical component. Because
Another
horizontally,
one,
yes,
if it asks the maximum velocity, sometimes I
it,
don't know I should write 0 or I should calculate the v. Because if it asks to calculate the maximum velocity, so why does it give marks if we have to write 0?
that is more towards you understanding the principle. Okay. When it is not, okay, at this point and this one, the V confirm not zero. Before it hits the ground, V is not zero. V is only zero at the maximum point.
Mm.
Okay? So if they ask you to calculate the maximum velocity, it's most likely it's hitting the ground. It's most likely hitting the ground. If they ask you what's the if it's a question they ask you something like what is the velocity at height so and so, then you can still use this. If you know the yeah, even if you know this, you have to still remember Vx. Okay, because the speed if they ask you for the speed like the component, right? It's Vx squared plus Vy squared. So you have to know Vx also. the Vy changes, but Vx remains the same. So this is a constant. This changes. Okay. So if you're asking for this as speed at this part, you have to calculate the whole thing using square root. Okay. But if they ask only for component, you can just use a component formula. Yeah, I don't know for use S equals to ut plus 1 over
So if the
2.
question asks for velocity, then I must do the theorem Pythagoras.
If the question asks for velocity, yes, you can always yeah, but see the question, they sometimes ask for horizontal component or vertical component, then you give
Okay.
component. Okay,
Mm.
okay, when up tangent, okay, and up tangent slightly, but okay, still have to. All right. Okay, now it's 9:45. We started class this one. Okay, how about maybe a 10-minute break? We did how many questions? One, two,
The
three,
class
four.
end at 10:30.
It's okay. I'll extend it a bit, maybe around 10:45. I'm still waiting for
Oh.
Brian to show up. I don't know where the guy went.
Mhm. Just going to watch the recording.
I think so. Just kind of watch recording now. It's okay. No, man.
Mm.
Okay, let's have a 5+ minute break. Yeah, then I'll see you guys then. All right.
Bye.
All right. I'll see you in 5 more minutes. Yeah. Yeah. Okay. Yeah. So for questions like this, yeah, you just have to find the area. So, but before that, define the work done by a force.
Mm.
You can also use another definition. I sometimes I use this definition as well.
But the definition at the start, can I use the same?
Yes, can also. But this one I like more because it's simple.
By
I just say the scalar
the
product of
product. Mm.
the force vector and the displacement vector. That's all. I really just say this.
I'm not able to see the last one.
Okay,
Okay.
later. This like this.
Force
Yeah.
vector.
Sorry.
So
The
this one
scalar.
basically from the formula, right?
Yes. Directly from the formula. Just say what define the work done by force is the scalar product of the force vector and the displacement vector, and you have one mark already.
Displacement. Mm.
The thing I
Okay.
like to write this one when they ask for define. Okay, because
Mm.
easy to remember. You just remember the formula, you can remember this. Okay, work done by the force in the interval. Okay, this is quite easy. Let's find from here to here, here to here, and here to here. Okay, this will be
Okay.
2 will be
Triangle.
negative. 2 will be
Ah,
negative. 4 to 7 will be negative. This will be positive. Yeah, yeah, this part. This will be area under the graph. So area under the graph, enter 0, this is positive. Here will be negative. 1 to 7. And then 7 to 9 will be positive for them.
mm.
Okay. I think you should get 15 joules. Then negative 4.5 joules
Mm.
and also 4 joules. Did you get?
Yes.
Okay. And then they ask, they only ask that, okay. If they ask for total energy, what do you do? For the total energy is plus
The,
everything again.
the
So
third one. The third one. 15 minus 4.5. Right.
15 minus 4.5 plus 4.
Plus.
4. Oh, sorry. This one, not 9.
15.5.
Okay. Maybe I should write it like this. This is 4. This is 4. Yeah. 7 to 9. Okay. From 4 to 7 is negative 4.5, and then this part is 15. So just plus everything together when you ask for 0 to 9, and you will get a sum of 14.5.
Mm.
Okay, then just okay. Okay, I have some extra questions here. Okay, let's just go through these. So very quickly, very briefly. Quickly. Okay. Okay, now
Mm-hmm.
these are all potential energy and kinetic energy questions. Okay, these are all just you can I think question A just here. Okay. The car and lorry travel on an even road. They have equal momentum. Which statement below describes the car and the lorry correctly? Okay, the car travels. Okay, remember the ball I mentioned before? Bigger ball,
Mm-hmm.
smaller ball. If you have the same momentum, you pick it with the same power. Which one will travel further? Smaller ball, right?
Yes.
The bigger ball will travel shorter. Just remember that. Okay, okay. So the car has traveled slower than the lorry. No, confirm no. Okay, the car is greater kinetic energy. Okay, let's see. Okay, maybe we can put this on hold first. Okay, both the car and the lorry have equal kinetic energy. No, I don't
No.
think so. Both the car and the lorry travels at the same speed. Confirm not. Okay, what
Mm-hmm.
would it be? Okay. A block of mass 1.6 is moved with a velocity of v equals to horizontal frictionless plane to compress a spin of spin constant. Okay, they give you here. Okay, they give you T. T equals to 1000 meters every time. Meter per meter. Okay. A block is block to rest after it is compressed by 2 cm. Calculate the velocity. Okay. So it moved here by 2 cm. So we have to calculate the velocity. How do you do that? Okay. So this one you remember, like I mentioned just now, PCM, PCM, either it's PCM or the PCE. Okay. Conservation of momentum, conservation of energy. If you have two things that are moving, moving a momentum question. If you have something like one state of energy changing to another, like this one, I can clearly see spring and something else moving. Confirm, sir.
Here we cannot use the fx, f equals to
Uh,
kx. Cannot.
you will. Uh, how you use it is the change in kinetic energy is equal to
Mm.
the change in elastic energy.
Okay. Oh,
So
elastic.
that will be 1 over 2 mv squared equals to 1 over 2 k is maybe I like using kx squared. Okay. So,
Okay.
so this one you can just cut the 0.2, 0.2, m equals to 1.6. Okay, I think they mentioned mass here 1.6. Velocity vector, that's what we want to find. K, they already mentioned 1000. X also they mentioned is 2 cm, 0.0. Theta, 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 D, you should get 0.5. Perfect. Yeah. A ball of mass 0.5 is dropped from a top floor of a building. The speed of the ball is 3 meters per second when it reaches the sixth floor. What is the speed at the fourth floor, which is a distance of 15 meters from the sixth floor? So here at the sixth floor is 3.0. Then it goes another 15 meters. Okay, they want to find the speed here. This is the first. So how do you find this? Okay, this one you just use MGH. Okay, you have to still use the principle of conservation of energy. Okay. So the total energy, okay, there will be an initial energy, okay, initial energy, I mean potential energy, and then there'll be a
Potential equals to kinetic.
okay, the final potential energy and final kinetic energy is equal to the initial potential energy plus the initial kinetic energy. Okay. So we can
But we
just do
only
that.
have one. Huh?
We can, well, you only they only ask the change, right? What is the speed and the so you can just mention that UF
The
at
initial
the
all will be zero.
potential here will be zero. Potential final will be zero.
Why?
Okay? So let's say this is a zero, H equals zero. Difference is here is 15. So this will be zero now. Just assume this is zero. It makes our calculation easier. Now it makes our calculation easier. Because we don't know how far it goes. Right? You can go endlessly down. You don't know how much. Okay, you want to means you can. Okay, you want to do a very long one. Okay, you say every 2 floors is 15. So 2 floor that means that's another 15. That's another 15. You keep going, but unnecessary. Now you can just stop it here. Okay, so you'll get something like this. Plus 1 over 2 mv squared equals to mvh from 4.5 plus 1 over 2 mu squared. Okay, just input this thing 1 over 2.
The zero potential energy is zero
The
because
final potential energy because we assume that the fourth floor is the final floor. We are assuming that the fourth floor is the final floor. You like I said, you can count now all of them together, but you still have to minus all of these again. So unnecessary. You can use the what do you call it? The V equals to U plus AT this thing. Can.
Mhm.
And then you have to find all of this time and you have to find the time. Then you have to find so many things unnecessary. Let's put zero.
Then
Okay.
mm,
Okay. So MGH. MGH is 0.5. The G is G. I just keep it as that. And then H is 15. Now the change. Plus the initial.
but
Initially,
don't
initial.
understand when we
Pardon?
must. Like for the previous question,
Mhm.
we use the formula elastic energy equals to
Kinetic
kinetic
energy.
energy, right?
Hmm.
Okay. But now we are using the final and initial. So I don't
Okay.
know when to use
There's
the
always
final.
the okay. There's always a total energy here at something.
Mhm.
Okay, there's a total energy in all systems. Okay. And usually we like to sum up this total energy. Later you learn in semester 3. There's a curve law. Okay. Always like this. Potential and kinetic energy are always terbalik. When the potential energy increase and then decrease, the kinetic
Mhm.
energy will also then decrease and then increase. Imagine a yo-yo. Imagine a yo-yo. Okay. Imagine a yo-yo. Okay. At the lowest point, the yo-yo is the first at this point. Right? Okay. It has the lowest amount of potential energy, but has the highest kinetic energy. As you go up and up and up and up and up, you lose the kinetic energy and you gain back potential energy. And then you go down again. You gain back your kinetic energy. They are always at odds. The total kinetic energy and the total potential energy. So at any point, okay, they will always be at odds. Like at this point, it is let's say this kinetic energy is potential energy. So you take this much and you take this much, you add them together, you add I mean you take this much energy like the graph like this area right. One area, this area, and then you have another area. Okay, 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 here, okay, something here. If you plus them together, you will get the energy at the maximum. You get this much. Like that. They're always at odds. That's why in here we are saying, okay, the total amount of energy and any system that is forming, you'll have some potential, you have some kinetic. You always have some potential, you have some kinetic. But if we set up something like, okay, that is the lowest point, okay, like I mentioned just now, like in a yo-yo, I see the lowest point here. At the lowest point, no potential energy, all kinetic. When I turn it around, go up again, all kinetic energy, no potential energy, like that. So here we're setting up it in such a way that it has H here, at this point here, at the fourth floor. That is our lowest point. Okay, we're assuming that's our lowest point. So it has no more potential anymore. Okay, it
Mm-hmm.
only has kinetic energy. And then we see
I
here,
should just see the
uh-huh,
question and then I see what they give. If they give height, velocity, mass, then I just write potential equals to kinetic, like that.
yeah, that's okay. That, like I remember just now, I mentioned about the pattern recognition. Yeah, it comes to pattern recognition again. Sometimes you just start seeing the question and you just start doing. I have friends like that. Memang all 3 semester of physics they got not even A minus, always A. So there are people like that. So, okay, but that comes from doing a lot of questions, reading the question, a lot, understanding it. But the problem is STPM, you don't have much time. So uh,
Mm,
sometimes you have to work smart and hard at the same time, which is a bit hard.
yes,
Okay. But,
I must
uh,
study like you, even at
huh?
4 a.m.
Oh, right. Oh, I reply your questions. Okay. So this is how you do it. 1/2 mu squared. Since they give you the initial velocity, they also give you the initial mass. Your mass is constant at 0.5. Okay. This is b squared. I don't get to put b squared to b squared. Okay, 0.5, and then this is also 3. They give you the initial velocity. Theta, 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 theta. You can get the value in your calculator. It should be around 17.42. Second. Okay, get this. Okay, but oh, no. Sorry. Maybe 6 extra change. Should have misclicked that.
Actually, Zoom is not more convenient.
Um. Okay, anyhow, okay, back to class. Okay, you get 17.42. I think you can better round off this as 17 because they give all values as two significant figures. You give the answer in two significant figures and clean the answer. Okay, box of mass 40 is pushed up in inclined plane, length 13 and height 5 above the ground as shown below. If the force applied is 200, find the efficiency of the inclined plane. Okay, this is an efficiency question. Okay, this is more of the final chapter of this this chapter. Okay, when it comes to power is efficiency. You see the word efficiency, you have to have a power. Okay, so how do you solve this? You have to have a power means always as an input and output. Okay, right. So first we have to find our efficiency. So we have to find how much is output. Okay, over input, and then times by 100. Okay, all right. So how do we go about this? Okay, so find out what
They
is
use
the
the FV.
for this you can just use MGH. Okay, plus the power gain, right? So you're going from a point here to here. You're changing your G. You're changing your H value. So you can just use MGH those. Okay, you can say the uh, energy here is just
Power
J
is
gain.
equals to mgh.
Anything. Work. Find the efficiency in this. Okay, so just put work also. you still get the same efficiency. You put power, or work, you still get the same thing. Okay. So you can just do a W. Okay, work output and work input. So work output will be mgh. So what is work input? Work input will be the displacement. No. Power is not mgh. Work is mgh. Okay, maybe I mistakenly use them interchangeably. I see. Okay, no problem. Power is work over time. Work is energy. Energy is mgh. No? Okay, potential energy. Okay, so that's mgh. So what is work input? Work input will be how much you're putting in. Okay, so they're saying input is 200. Okay, they say they already give you the value is 200, and you're moving how much? You're moving roughly 13. Okay, you're moving here 13. So that is
Can you say
Fs.
again about the
Oh,
power?
power is work over time.
Okay.
Power is work over time. Work here is mgh. Okay, work here is mgh. Why mgh? Okay, if you notice here, okay, what is the output? Okay, what are you getting from doing this? A block moves 5 cm upward. That's all. That's what you're getting here. Okay,
Yes.
that is your
Mm.
output. So what are you inputting? You are inputting a power of 200 Newton across
Mm.
13 meters. That is your input. So Fs. Okay. So that will be m is how much? M is 40.
40.
Yep, 40. G times by 5.
9.815
And then Fs is
over
200.
200 times 13.
Yep, you will get around, don't forget times by 100.
75.
75 point whatever something
5.
but you'll get around 75%. So answer is B.
Okay.
All right. Just skipping a few questions now. Okay. Okay. Let's go back to the extra bonus questions. Straight away you can solve them. Okay. Now let's go to question 7. Okay. These are the more I would say harder questions.
Hmm.
Okay. P and Q are identical springs. The length of the spring is 29 and 35 respectively when it is suspended with a load mass K. So this is after being suspended, not before. So this is L plus X. Okay, both of them L plus X. 100, 160, 400. Assume the spring does not exceed the limit of proportion. That means it's still elastic. It's still elastic. Okay, so these are identical springs. So how do we go about answering this question? Okay. Okay, so what is the difference? I think we should find the difference in mass. So how do you find it? You find just minus. Okay, so it's delta m equals to 400 minus 160. You get 0.24 kg. Okay, then you find the difference in length. Okay, so that is 35 minus 29. So you get roughly 0.06 meters. Okay, so what do you do with this? Hooke's law, K equals to F over X. Or in this case, mg over X. So that would be 0.24 times by G over the change. Okay, so that's a 0.06. We'll get 39.4. I'm sorry, 39.2. This will be the spring constant. So n negative 1. Okay, now to B. what is the original length of the spring? Okay, then you already know how do you find out this? You find that F equals to Kx. Use this again. What do we do with this though? Okay, remember that it's mg equals to Kx. Okay, suspended. This one you can use the same way. That's the same force. Okay, the same force, not two different forces. So that would be 0.16 times, but you can take either one. I chose to take P. You can take Q also.
Why mg equals to kg? Why the x become
Oh,
g?
sorry. So sorry about that. 0.
Oh.
0.16 G equals to just now we got the K value 39.24 X, and then you can just find the X value, which is around
Mass
4.
not 0.24.
Okay, why we use 0.24 just saying? Maybe I'll go a bit too fast. Okay, what we are doing here now is actually remember the Hooke's law. Okay, remember the graph. Okay, the graph is something like this, right? So we are finding this point and this point. Okay, because you know at this point got F, X here, got what F here. At this point got another X here, got F here.
Are you talking?
Yes, I am talking. Can you not hear me?
Okay.
Can I? Okay. So we have one X here, and this is my P now. This is P now. So we have 2 points here. So we're actually finding a gradient. Remember, K is just the gradient. So you can also use K like this, y1 minus y2 over x1 minus x2. That's what I essentially did here. Okay. y1 minus y2 minus x1 minus x2. That's what we did here. Okay, but here I just did m1 minus m2 g, because g is constant, over L1 minus L2. We still find K. That is why we minus 2 just now. You can do straightforward. You can just y1 minus y2 also, can also. But I wanted to separate the values. You can do it straightforward also, no problem. Okay, and then you can also use both of them. Okay, here I use 0.16 G. You can also use the other one. Here also you can use this one also. 35 and 4, you can also use that one. Okay, mg equals to kx, you can also use that. Okay, you still get the same answer. So, but I'm using P for now. So since I'm using P, I'll get
The mg.
Yeah, I think okay, 4 lah. So you know it's 4.
The mg for the previous question.
mg for the question.
This question, but k
A.
equals to f over x.
Yes.
The m, are we taking from delta m?
Yes. 0.424 G. Yeah. Then we can find the x, and then we just minus k is the same thing. We can do it for this one also, the other way. This is 400, right?
I didn't get 39.24.
What did you get? 24 over 0.06.
Because I did 0.24 times 9.81.
Yeah. Yeah. Over 0.06, right?
Yes.
You don't get 39.24?
0.24 and 9.81
Yes.
divide
0.
0.06. Okay,
You
now
get
I'm
39.
getting.
Okay, you got up. Okay. Okay, then you just, if this is the
Okay.
first one, this is the
FMG.
first string. You get this value, you get this x. If you use the first one, because do it for the other string also. Okay, let's say the other string is 400, right? 400g equals to 39.24 x. Okay, how much do you get? Okay, x equals to, oh sorry, actually, it's 0.4. Okay, then it's SI unit, right? Okay, so that is 0.4 equals to 39.24
Again,
x.
I'm not getting for.
Are you sure you don't get 4? 0.16 over
Isn't that
39.
0.24 gram?
You'll get 0.04. You'll get 0.04 m or 4 cm around here. Yeah, your the actual value you get is a 4.0777 times by 10 to the power -3. You get this value, which is the same as 4 cm, 4.077 cm. You don't get this?
So I get 0.04. Why did you write 0.16?
Kilograms, SI unit.
Huh? 0.24, right?
You don't, okay. Let me explain the question again. Okay.
Okay.
For the first question, we want to find the force constant. You can find the force constant by using the gradient formula y1 minus y2, x1 minus x2. Okay, I did it separately to get 0.24 and 0.06. Alright, and then I just put it back in the formula. You get 0.24g over 0.06. You get 39.24. And then they want to find
Okay.
what is the original length of the spring. For that, you have to come back to either one of the springs.
I
You
get
can
it, but I get my answer is 0.4.
you should get 0.04.
Okay. First, I did 1.6. 1.6 or 0.16.
Mm. You should get
0.
4.077 10 to the power -3.
Okay, I get 0.04.
Yep, got it. Okay.
Hello.
Yeah, hello. You got it? You got it down? Okay. So you can also do it for the other method also. 400, right? 0.4. So you can also do it for the other mass. You can also do it for other mass. 0.4 over 39.24. You'll get around 0.102. Oh, sorry, 0.0102. Okay. So no, you should get 0.004, is it? You get 0.004. Did I miss an extra zero? Yeah, 1, 2, 3. Yeah, I missed the extra zero. I should get 0.004. For this one, you'll get 0.102. Okay, all right, let's try.
Hello.
Yes, hello.
Hello.
Can you hear me now?
I still get 0.04. I did 0.16
Uh-huh.
times 9.81 divide 39.24. The answer is 0.04.
Wait. Yeah, correct, correct, correct. Yeah, you should get 0.05. Yeah, hey, what am I talking about? Yeah. G, G, you should get say x equals to 0.04 meters, which is
The second one, I get 0.1.
0.1. Yeah, 0.1. Yep, yep. You should get these two. Yeah. Okay, then you can use both of them respectively. Okay, so
Meter, right? Meter.
you can give it
X.
in, oh yeah, meter. Yeah, it's meter. Okay, so that means that this has elongated 10 cm, this has elongated 4 cm. So
Mm.
29 minus 4 is 25. 35 minus 10 is 25. Still the same answer. You can do it both ways also.
So I need to minus
Yeah, elongated what? You put a spring, it gets longer what? So you can either get
29
35.
minus minus 4.
Yep.
இந்த கதை நீங்க சாப்பிடு கூட்டாத
Okay, either 35 minus 10 or 29 minus 4. Both are accepted. Yep. Okay, now how many questions we have? Okay, we have 1, 2, 3, 4, 5. Okay, how about okay, we have not much time. We can do, okay, let's try to do one hard question. Okay. I would say this is the hardest question among them. Later I'll post these other ones are posted in the exercise along with some other questions and also the bonus lah.
Okay.
Okay. Let's try this one hard question. Okay, let's read out the question. Okay. Car M moves from rest with velocity of v after traveling a distance of s. Right? Do you have an expression for the kinetic theory of the car? Okay, this already seems like what do you call paper section. I mean section C question already. If you ask like derive, or it's like already section C already. Okay. A rock of mass 2 kg
I
falls
must
from.
mgh equals to half mv square.
Mm, okay, this derivation actually is from something more basic. Okay. Okay, I'll give you a trial run. Maybe I can try it again. Okay. See the okay, I mentioned a car of mass m moves from rest with a velocity of v of traveling a distance s. Okay. V m s. Okay. What comes to my mind when something is traveling from rest? So that means that's u. In my mind, this comes out. V squared equals to u squared plus 2as. This is what comes out to my mind. Okay. So why does this come out to my mind? Okay. It's because that I can simplify it. Okay, we know that u squared is 0. So v squared equals to just 2as. And then I can also say that as equals to v squared plus, sorry, v squared B square over 2. Okay, why, sorry. B square over 2. Okay, why is this important? Okay, I want to emphasize on the W again. Okay, why work is important. You can derive this in many ways. Like remember the first question we did? You can derive it with integration of mass. You can integrate Hooke's law. You can do a lot of things with it. So, but in this sense, I'm going to do something.
Now I did like this. E equals to half mv square. And then the half m, at the v square, I wrote 2as. Can?
But you throw apart MB square. But what they want is the MB square. They want you to find MB square. So that cannot be your initial. That has to be your final. Okay. So in that sense, what you can do, as I mentioned it like this, okay. So work equals to force times displacement, and you know that force is just a product of mass and acceleration. So in here, I got acceleration, I got displacement. Just now I got here also acceleration, displacement. So I can also put mass equals to velocity squared over 2. Okay. And I can also write that as 1 over 2 b squared. That's the one kinetic energy of a car. Okay. That means that it comes back to work here. Okay. So this is how I do. There's another way you can probably do also. You can just say, oh yeah, there's some other ways you can do also, but I did not write it down. I try to find the other ways later. I'll post it. Since we are a bit short on time, I'll try to make this task quick. Then you can just say the energy, kinetic energy, is equal to 1 over 2 v squared. Why we can just say that is because the work done by the car, whatever power the car was using from the engine, everything is converted to kinetic energy. Let's say Ek equals to 1 over v squared. That's B. That's A. Okay. Oh no. Let's try B. Okay. So B. Alright. So a rock of mass 2 kg. This is the diagram. The diagram was from B, not A. Okay, falls from a cliff of height 160 and sinks 1.5 into the ground. This already looks like to me V equals to U plus KT type of question. So maybe or a MGH question, so like or like an energy conservation question. Yeah, some we don't know from one certain point to another certain point. That looks like to me an energy conservation question. Okay. So and they also ask calculate the total energy at point A. Okay, remember the total energy at any point for any object is always the sum or its potential component and its kinetic component. So you can always say that at point A, it's equal to the kinetic energy plus potential energy. So that will be, let's say it's not moving, so assuming it's not moving at all. So kinetic energy is 0, and then you just plus potential energy, which is given by gravity. So that's just mgh. So that's just a 2 g and then 160. So that is just you can just put. I don't like to put it as maybe you like to put it as 320 g, 320 g. Better not. Better you open the g and just give it a value 3139. Give it the joules. I know that sometimes you feel a bit lazy, right? You just want to give the answer like 320 g. Yeah, but sometimes you have to remember. Usually your markers for your paper are quite old-fashioned, really seasoned. That's the word I like to use, seasoned people. So they don't like to play much. They are very straight to the point. So better give them what they want. Because at the end of the day, if your paper is being marked by a person, okay, we don't know how their mood is that day, who they fought with, and everything. So it's best to be safe. Okay, so just give the value to them. Don't take the risk. Okay. Then calculate the kinetic energy at point P. Okay, so here you have to remember PCE. Okay, principle of conservation of energy. Energy is conserved. So if something is increasing in kinetically, it has to decrease potentially. Okay, so that means that UF plus KF equals to UI plus KI. So that means
Where are you writing?
on the board here. Can you not
You
see?
writing?
Yes, I'm writing.
I cannot see.
Maybe it's an internet problem. Okay, sorry. Okay, so okay, then we know that initially, okay, this is 0. Okay, final, let's say this is final 0. And just now we mentioned that at point A is 3139. So we just need to find the kinetic energy.
Here, why the kinetic energy is 0?
Kinetic energy at A is 0 because it's we are assuming it's not moving at that point. Okay, we are assuming it doesn't move at this point.
Potential?
Potential has potential is be the MGH. Okay, the potential will be MGH, and then at the bottom is the
Like for the
opacity.
previous question, we said MGH is 0 until 4th floor, right?
Yeah. So fourth floor we assume as the last floor. Same here also. Potential is 0. Final potential here is 0. Same thing. See? UF potential is 0. Kinetic ada potential is 0. Then we calculate just now A how much? 3139. So just put okay. And we get directly KF equals to also 3139. Same process. But they want to see this. They want to see this. Very important. They want you to know that oh, this person has equated the change in energy. That means they are saying that energy is zero. Okay. Okay. Now let's go to the final question. I calculate the retarding force. Okay. Retarding force decreasing again. Okay. So we can just use the formula again. You can just
I
say
kind of don't understand the question B, but
okay.
never mind. We do C first, and then I think again.
Okay, it's all right. I can go through it. It's not really a problem. Okay. Okay, question B. Okay, let's see. Okay, a rock of mass 2 kg falls from a cliff of height 160 and sinks 1.5 to the ground, as shown in the diagram. Okay, okay. So the first question they ask is calculate the total energy at point A. Okay, let us assume at point A is where it starts. Where it starts. Okay, it did not move before this. Okay, it did not move before this. So this is where it starts. So when something baru starts, does it have any kinetic energy? No, it does not have any kinetic energy. Okay, kinetic energy is 0 at the start. But does it have potential energy? Yes, potential energy ada. Okay, potential energy. How do we calculate potential energy? We calculate potential energy by mgh. Okay, mgh. So at A, no kinetic energy, but has potential energy. And like I mentioned just now, potential and kinetic are always related. When something increases, like a yo-yo, always remember the yo-yo. When something increases in kinetic, it decreases in potential. Okay.
Is
So
it
when
always potential 0, kinetic energy have? If kinetic energy 0, potential
yes,
have
it,
a number.
always the always. So when kinetic energy is full, potential is 0.
Always one must be 0.
No, at maximum points at the point. So this is the point where it starts. At the point
Oh,
where it
okay, okay.
starts, logic, something is not moving. It doesn't have any kinetic energy. Okay,
Mm-hmm.
so kinetic energy is zero. Unless potential. So that's why we take MGH. At the end of it, at this point, we know that it stops moving. So yes, it stops. The height is zero, so it's very close to the ground, but still has kinetic energy. So kinetic energy will be all the energy is just transferred just now. So kinetic energy will be equal to mgh, and potential energy will be zero.
Mm-hmm.
This logic. Okay. So this same logic applies to A1 and A2. Just now at point A, kinetic energy is zero, potential energy is maximum. A equals to mgh 3139. At the opposite point, when
Welcome.
it stops at B, then we know that at B, the potential energy is zero, kinetic energy is maximum, and we already know A 3139. So kinetic energy at the final point is also 3139. Okay. And then finally, let's use number three. Logic number three, calculate the retarding force acting on the rock in the ground. Okay. So just now I mentioned it actually sunk into the ground, sinks into the 1.5. Okay. So we have to find the retarding force. They did not give us a time, they did not give us a time frame. Only that is sunk 1.5. Okay. So if it's sunk only 1.5, that's all we can work with. Okay. So let's remember again. Okay, W equals to 1 over 2 mv squared. And W is Fx or Fx. Okay, Fs or Fx. It's up to you. 1 over 2 mv squared. Okay. So since it says sunk to the ground, that means there is a change in velocity. From whatever the velocity was, it changes to zero. So we know that the energy at B, just now B here, was 3139. But when it sinks to the ground, what is the energy? Zero, because it just stopped moving. What? Okay? When it stops moving, velocity is zero, and hence energy is also zero. So delta is 3139. So Fx equals to how much? 3139. And how much is x? We know that x equals to 1.5 equals to 3139. And then finally, we can say that the retarding force F equals to 2093 meters. Okay, did you get this answer? 2093? Yes?
Yes.
Okay. So, okay, again, I'll explain again. Calculate the retarding force. Retarding force means it's slowing down. Okay, it's always slowing down.
Oh, I cannot
So,
hear. Can
uh,
you please say again?
okay, I'll say it again. Retarding force means that it's always slowing down. Okay, but why we cannot use the impulsive force formula where it says mv minus mv over p? Okay, the
Okay.
reason is simple. It did not give us a time, so we use
Hmm.
this method. Since there's no time, if they give us a time, we can say we can use the time formula. Okay, but here they did not give us a time, so we cannot use time. That's all. So we use it in this way. Fx equals to 1 over 2 mv squared. Okay, let's say they give us an example. I'm just saying as
So
an
whenever
example.
the question have the word retarding force,
Yeah,
whenever the question has the word retarding
yeah, yeah,
force,
yeah.
must have kinetic and potential.
Yes, all of those things will come together. They're always like a sandwich, like sandwich. Got your roti, got your telur, got your sayu. It's always like that.
Okay.
It's like a complete question. All of those things will always come together. Okay,
Okay.
all right. Okay, so That's all.
Okay. Bye.
Okay. All
Finish.
right. Any questions first? Any questions before class ends?
Yes. I have a question, but then I will think and then I will message you.
Okay. Sure. Okay. I'll
Okay.
send this the recording later because I have
Mm-hmm.
to process the recording card a bit. Okay. Then I'll upload. Okay. I'll upload finally the notes. Okay.
Mm-hmm.
So I'll try to do it before tonight. Okay. All right.
Okay. I will
Okay.
submit the physics exercise.
Okay. Take your time. I already put like a long attention. Okay. Don't worry.
It's okay. I will submit before the due.
Okay. All right.
Bye.
Okay.
Thank
Have a
you.
good rest. Okay. Enjoy your weekend. See you tomorrow.
Okay.
All right.
Tomorrow. Oh yeah, tomorrow
Yep.
evening.
Monday. Yep.
Okay.
Evening 4
Bye.
p.m. All right. See you. Well, have a good day.